Calculus, here we are. Hopefully your last notes video from home. This one is made a full week in advance. You should be watching this on Monday the 18th. This is being made on Monday the 11th. I hope to be with you on Tuesday the 19th. Folks, as always, we have our in-house sponsors of Crystal Lights, pure energy. Noon, electrolytes plus energy. You can see it's clear energy theme here. And Cliff Bar, we're planting 1 million trees. Excellent. That's going to be a lot of game plans I can make. Laura Bar as well in class studio one more time. Here we are. They've been a great, very attentive, relatively quiet bunch today. And of course, our lovely sponsor for the next few months, Knee Rover Knee Scooter, currently being used by Stuart. All right, folks, let's get at these notes. After today, you can handle any and all questions with limits involving infinity. Evaluate each limit if it exists. If it does not exist, we will simply say the limit does not exist. You can say that instead of, oh, it's positive infinity or negative infinity like we talked about on Friday's notes. Okay, the limit as x goes to infinity. Okay, again, what's the square root of infinity? It's infinity. Infinity minus infinity, you can't say infinity minus infinity, it equals 0. If it is equal to 0, and sometimes they will be, this answer will in fact be 0, you have to show me why it's 0. You can't say infinity minus infinity, that won't earn you. I'll give you a quarter of the points. You don't want a quarter of the points. So what are you going to do? You are going to, well, let's try and see if we can get rid of this root in a meaningful way, and I can multiply the top. You're like, Mr. Jack, there's not a bottom. Well, now there is. Multiply the top and the bottom by the conjugates. All right, so I multiply there and there by the square root of x squared plus 1 plus x. And when I do that, root multiplied by itself, the root goes bye-bye. You're going to have x squared plus 1 minus x squared. And that's the limit as x goes to infinity. All right, which is great. The denominator just has the conjugates. Take a look at what's going to happen here. The x squareds will cancel. I'm going to have the limit as x goes to infinity of 1 over. Now, here's what we can do from Friday's notes. Again, this is essentially, because that one's not going to be useful, this is now essentially the limit as x goes to infinity of 1 over the square root of x squared plus x. Well, I know exactly what the square root of x squared is, and that's x. This is the limit as x goes to infinity of 1 over x plus x. X plus x is 2x. Where's the highest power? The highest power is in the denominator. If x goes to infinity, this is going to be 1 over infinity. 1 over infinity is 0. And the highest power is now truly in the denominator. If the highest power is in the denominator, your horizontal asymptote is y equals 0. So the limit as x goes to infinity is y equals 0. All right. Or the limit as x goes to negative infinity. If the highest power is in the denominator, the horizontal asymptote is 0. All right, so take a look at this one, and before you write x equals 0, it is not x equals 0. We, again, are going to do the same exact approach here. We're going to call this over 1. I'm going to multiply the top and the bottom by the square root of 9x squared plus x plus 3x. Top, bottom. So when I do that, it's going to be 9x squared plus x minus 9x squared. All over the conjugates. 9x squared minus 9x is x over that. All right. Again, this is essentially, because believe it or not, you know if x is going to go to infinity, you're like, but that's not going to be inconsequential there. That's going to be infinity. But you always just look at what's the highest power of x, because that's going to be the thing that is most important. So that's going to be 9x squared. All right, we just we just write 9x squared because that's going to have the most importance there. Okay, that is it's the biggest exponent. What's the biggest power? We're going to say that is essentially the same thing as writing 9x squared. All right, so then I know that, again, we always use, this is approximately. So when I take the square root of 9x squared, I get 3x. 3x plus 3x is 6x. The limit as x goes to infinity, you have x over 6x. X's cancel. The highest power is both in the numerator and denominator. So my answer is 1/6. And we could have gone like the long way. We could divide everything. What's the highest power in the denominator? Believe it or not, it is x. I could divide this by x, that by x, this, because it's inside the square root, by x squared. So this would then be x over x squared, which is 1 over x. That would go to 0. And this would just be 9. All right, so you would have 1 over root 9 plus 3, which is 1 over 3 plus 3, which is 1 over 6. Okay, but again, using the essentially, this is approximately the same thing as, gives us the same answer. Okay, than that long approach we talked about the other day. All right, I've got another one of these. Again, it's not infinity minus infinity is 0. We're going to multiply the top and now give it a bottom by the conjugates, which is root x squared plus ax plus root x squared plus bx. X squared plus ax minus all of x squared plus bx. All right, over the conjugate, the x squareds are going to cancel. You're going to have ax minus bx. Yes, you have to write the limit as x goes to infinity. All right, again. Instead of having, I got to divide everything by the highest power in the denominator, which is technically x, because the square root of x squared is x. I can just notice that that's the highest power, that's most important. That's the highest power, that is also most important. I don't have to divide everything by x up top or x squared in the square roots to show that this is eventually leading here. Instead, I can say this is essentially the limit as x goes to infinity of ax minus bx over root x squared plus root x squared. It's all about the highest power in that root as x is going to infinity. All right? Well, the square root of x squared is x. X plus x is 2x. I factored out the x that's attached to both a and a negative b. And look what happens. The x's cancel. A minus b over 2. Again, I will show you more of these examples on Tuesday in class. I'll give you kind of one of each to just go over that. It takes any questions you might have. We're just going to get as much as we can in these notes from home. The limit as x goes to infinity of the square root of 16x squared minus 1 over 5x plus 7. Again, right away, what's most important? As x goes to infinity, it's that and it's that. That negative 1 and 7 can go bye-bye. This is essentially the limit as x goes to infinity of the square root of 16x squared over 5x. The square root of 16x squared is exactly 4x. X over x cancels. 4/5. All right. Let's take a look at example 5. Example 5. So here's how you can do that. What's the highest power? That's most important. That's most important. So this is essentially the limit as x goes to infinity. You can write it exactly like this, of the square root of 3x to the 4th over 5x to the 4th. Going to take the square root of x to the 4th. That's x squared. Over x squared, you got a root 3 over root 5. The x squareds cancel. And you have root 3 over root 5, which you may write as that as well. Okay, these notes are going to be a tad shorter. I just got 3 more. And here's what you're allowed to do, okay? For your homework. and a quiz. And I gotta be very careful because unfortunately these can be some of the easiest questions, but students don't examine them closely enough, and instead of getting 3 out of 3, they get 0.6 out of 3 because they get it wrong and they don't show any work. So the limit as x goes to infinity of this rational function. You have the same highest power, so you're going to write same highest power. So thus, this is essentially, just look at those leading coefficients, the same highest power. This is essentially the limit as x goes to infinity of 3x squared over 5x squared. Again, I don't have to divide everything by x squared. All right, if you have the same highest power in the numerator and denominator, the limit as x goes to infinity, or the horizontal asymptote, is going to be the ratio of the leading coefficients, which is 3/5. Okay, so you can write the same highest power, right? It's essentially the limit as x goes to infinity of 3x squared over 5x squared, which is 3/5. That will be acceptable. All right, the limit as x goes to infinity. What you're going to do here is you're going to show that, hey, the highest power is in the numerator. I don't have to do the long way of dividing everything by the highest power in the denominator, which again, in future classes, you need to be cognizant of that. If I divide everything by x, highest power in the denominator, this is what I'm going to have. And the limit as x goes to infinity, it's going to be, infinity over 4, which... little sneeze break there. Infinity over 4 is still infinity. All right. Again, the highest power is in the numerator. The limit does not exist. You don't have to write equals positive infinity. In some cases, negative infinity. You can just write the limit does not exist. But be prepared next year to know how to write it like that. Divide everything by the highest power in the numerator. You have infinity over 4, which is still infinity. The limit does not exist. Highest power in the numerator. We said in college algebra that the horizontal asymptote, there is none. There's no horizontal asymptote because the limit does not exist. Be very careful on example 8 here. This right there. So in the denominator, we can clearly see the highest power is x to the 3 over 2. Unfortunately, too many people are not going to notice that the highest power in the numerator is also x to the 3 over 2. And I say, oh, highest power is in the denominator. The limit is 0. I see this all the time. So be careful here. So this has to be a higher power. X times root x has got to be a higher power than x to the first. So again, this is essentially limit as x goes to infinity. Negative 3x root x over 7x to the 3 over 2. X times root x times x to the 1/2 is x to the 3 over 2. Now the exponents in the numerator, the highest power in the numerator and denominator is the same. So the limit is equal to negative 3 over 7. And then, if you saw this, if you had like a really easy one, let's do one more. The limits as x goes to negative infinity over 4 plus x over x squared plus 3. All right, so what's going to happen? The highest power is in the denominator. If the highest power is in the denominator, the horizontal asymptote is y equals 0. The limit is 0. Again, I can divide everything by the highest power in the denominator, which is x squared. Going the long way, I divide everything by x. I don't want you to get caught up with the negative infinity thinking that, the answer is going to be negative here. If I divide everything by x squared, I'm going to have 4 over x squared plus 1 over x over 1 plus 3 over x squared. If you let x go to negative infinity, it's going to be 0 plus 0 over 1 plus 0, which is 0. If the highest power is in the denominator, the limit as x goes to infinity or positive infinity is 0. Again, be prepared to show this type of work in future classes. But if the highest power is in the denominator, you can simply say, write that the highest power is in the denominator. So the limit as x goes to negative infinity is 0. Be prepared to know how to do that, though, for future years. Okay? Anyway, that is it, hopefully, with the notes videos in my absence. Folks, it's been great. This is Yak Math Videos signing out.